Hello students, welcome to my class of NLP. Let us see in today's session what is the difference between human language and computer language, how humans will process the language and how the computer can process the language. When we come to human language, humans communicate through language which we process all the time. Our brain keeps on processing the sounds that it hears around itself and tries to make sense out of them all the time. As a person speaks, the sound travels from his mouth and goes to the listener's eardrum. The sound striking the eardrum is converted into neuron impulse, gets transported to the brain, and then gets processed. After processing the signal, the brain gains understanding around the meaning of it. If it is clear, the signal gets stored. Otherwise, the listener asks for clarity to the speaker. This is how human languages are processed by our brain. Now, when we come across how the computer will understand the language, on the other hand, the computer understands the language of numbers. As we all know, the computers can understand only zeros and ones. Everything that is sent to the machine has to be converted to numbers. And while typing, if a single mistake is made, the computer throws an error and does not process that part. The communications made by the machines are very basic and simple. Now, if we want the machine to understand our language, how should this happen? What are the possible difficulties a machine would face in processing our natural language? Let us see. Now, let us see this example, how the words are arranged and how the meaning is being depicted. As we all know that we have so many human languages, like we have many languages that humans speak. Okay, so in any language, we have nouns, verbs, adverbs, and adjectives. Now, a word can be a noun at one time and an adjective some other time. There are rules to provide structure to this language. This is the issue related to the syntax of the language. Syntax refers to the grammatical structure of the sentence. When the structure is present, we can start interpreting the message. When the message is in proper manner, we can easily understand. Now we also want to have the computer to do this. One way to do this is to use part of the speech tagging, and this allows the computer to identify different parts of the speech. There are multiple characteristics of the human language that might be easy for a human to understand, but extremely difficult for a computer to understand. Let us see one example in analogy of programming language. Here we can see different syntax, but same semantics. The way these statements are written is different, but their meanings are same. That means when you add 2 plus 3, we get the result same. And when we add 3 plus 2, we get the result same. This is an example for different syntax, same semantics. Let us come to the next scenario, different semantics and same syntax. Let us see in Python 2.7 version, when we write 2 by 3, that output is not similar to the output that we get in the Python 3 version. Even though these two statements, that means even though you are writing this expression 2 by 3, you don't get the same result. The statements written have the same syntax, but the meanings are different. In Python 2.7, 2 by 3, the result of this 2 by 3 would be 1, whereas in Python 3 version, the result of this 2 by 3 would be 1.5 as the output. Now, when we see the next scenario, multiple meanings of a word. Let us consider these 3 sentences. His face turned red after he found out that he took the wrong bag. What does this mean? Is he feeling ashamed because he took another person's bag instead of his? Is he feeling angry because he did not manage to steal the bag that he has been targeting? Now let us see the second sentence. The red car zoomed past his nose, probably talking about the color of the car. If you see, this red is talking about the color of the car. His face turns red after consuming the medicine. The text is the same, but is he having an allergic reaction or is he not able to bear the taste of that medicine? So this text is talking about the allergic reaction. If you see in all the 3 sentences you have taken, the color red depicts a different meaning in every scenario. This is multiple meanings of a word. This is how, now let us see how our natural language processing makes it possible for the machines to understand and speak in the natural language just like humans. For that, let us see text normalization. Since we all know that the language of computers is numerical, only the computers will understand the language of the numbers. This conversion takes place a few steps to happen. So, the first step that we come across before the language is converted into numbers is the text normalization. Now, what is text normalization? Text normalization helps in cleaning up the textual data in such a way that it comes down to a level where its complexity is lower than the actual data. That means the complexity of the text should be reduced to the lower level. That is the use of text normalization. Now let us see the word corpus. What does this word corpus mean? The term used to describe the whole textual data from all the documents all together is known as corpus. So when we are talking about text normalization, the term corpus arrives. Now let us see here how the text normalization happens. The first step of text normalization is to gather, to collect, right? So for that, what we are using? The whole corpus. This is called as the corpus because these are all the sentences that I have gathered from different documents. This I call it as the corpus. Now, when I apply sentence segmentation, this whole corpus is being divided into different sentences. Each sentence is taken as a different data. So now the whole corpus gets reduced to sentences. Now, this is the whole corpus that we have been divided after applying sentence segmentation. We get 2 different documents where each sentence refers to one document. In our next step, we are also talking about tokenization. So, after applying sentence segmentation, each sentence is then further divided into tokens. Now, We have taken only the first document after sentence segmentation, and now this document is being divided into tokens. We have to make sure that tokens is the term used for any word or even a number or at least a special character. That means if you see even comma is counted as a token, then hyphen is also is considered as the token. Dot is also considered as token. Tokens are nothing but not only the words, it can be the numbers, special characters also. Under the tokenization, every word, number, and special characters are considered separately. Now, if you see in this example, this document, after applying tokenization, this is how it looks. The next step after applying tokenization is removing the stop words, special characters, and numbers. Now, in this step, the tokens, these are the tokens that we got from the previous step of tokenization, and now we are removing the stop words. Now we have to know what are stop words. Stop words are the words which occur very frequently in the corpus but do not add any value to it. The tokens which are not necessary are removed from the token list. So in this previous step, if you see, we have tokens like comma, hyphen. You can see V is repeated thrice. Okay, what all are repeated twice or thrice, those are all removed. So removing the stop words, then the special characters and also the numbers. So you might be clear now. Stop words are nothing but which occur very frequently. We call them as the stop words. Now, why are we removing these stop words? Let us see the reason. When we humans use the grammar to make the sentences meaningful for the other person to understand, they are very important. But grammatical words do not add any essence to the information which is to be transmitted through the statement. Hence, they come under stop words. For the machine, these stop words are not important because they don't add any value or any meaning because they are occurring n number of times. More number of times the stop words occur, they have less value in the corpus. These words occur the most in any given corpus but talk very little or nothing about the context or the meaning of it. Hence, to make it easier for the computer to focus on meaningful terms, these words are removed. After removing the stop words, special symbols, what is the next step? We make sure that we are converting the text to a common case. That means, for example, let us see the word hello is in different textual case sensitivities. Different capitals, small letters, capitals are mixed. So you have different representation of the same text. Now, to make it in a uniform way, what we are doing, we want to convert the text to a common case, that is the lower case. This ensures that the case sensitivity of the machine does not consider the same words as different. Now, if you see, this word is different for the computer and this word is different for the computer. But all this different representation of the same text, once converted into lower case, similar case, that is lower case, the computer understands that it is of the same text. Now, after converting into the case sensitive, that means lower case, next comes stemming. Now, let us see what is stemming. In this step, the remaining words are reduced to their root words. So, what is stemming? Let us see here. Stemming is the process in which the affixes are removed. Affixes in the sense ed, ing forms, er, es, ing. So these affixes are removed and these words are converted into their base form, which we call it after applying the stemming and after removing these affixes. We call these words as stem words. So stemming and lemmatization both are very similar, but they are alternative process to each other. That means either we use stemming or lemmatization in our process. Okay, so lemmatization is also the same. What we are doing? We are removing the affixes ed, ing, er, es, ing. But the difference between both of them is that in lemmatization, the word we get after the affixes removal, we call those words as lemma words, which are meaningful. That means lemmatization makes sure that lemma is the word with meaning and hence it takes a longer time to execute than stemming. Let us see. This is the difference between lemmatization and stemming. If you see in stemming, only the affixes are removed, but the stemming process will not care about the actual meaning of that particular word. But lemmatization makes sure that after removing these affixes like ing forms, it also makes sure that the actual meaning does not change. So when you remove this affix ing, you get care as the lemma word, and when you remove ing form, ing affixes, when you remove this, you get it as car. So here, stemming is the fastest process we can say, and lemmatization is time taking because it makes sure that the meaning of the actual word remains the same. Hope you understood what is the difference between lemmatization and stemming. Now, to convert the tokens into the numbers, we use the bag of words algorithm. So now we got these tokens. So these tokens are to be converted into numbers. For this purpose, we will use bag of words algorithm. You can see in this picture that this is the whole corpus where by using the bag of words algorithm, these are divided into tokens, and finally after applying this process, at the end you can see how many times the word appears. That means this is called the term frequency. We will see about this in detail in our bag of words algorithm. So bag of words is the natural language processing model which helps in extracting the features out of the text, which can be helpful in machine learning algorithms. In bag of words, we get the occurrences of each word and construct the vocabulary for the corpus. Here is a step-by-step approach to implement bag of words algorithm. Let us see the first step. First step, we apply text normalization. So what is text normalization? First, we collect the data and reprocess it. Second step, we create the dictionary. Make a list of all the unique words occurring in the corpus. Create document vectors. For each document in the corpus, find out how many times the word from the unique list of the words has occurred. Step 4. Create document vectors for all the documents. These are the step-by-step approach to implement bag of words algorithm. Now, let us see how do we implement this using one example.